All right, everyone, thank you so much for coming out today. Welcome to the fourth webinar of the Climate Toolkit. It's a real pleasure to have you all with us. I'm Joe Reed. I'm substituting for Richard Piacentini today as our MC. Our conversation today is on climate change and water, reduction, collection, research, and outreach. We have presenters today from Santa Barbara Botanical Gardens, Science Museum of Minnesota, and Phipps to share their experience addressing climate change through research, education, and public outreach around water and water reduction measures. Before we get started, I just wanted to announce that we've had 6 additions to the toolkit within the last month. So a warm welcome to California Indian Museum and Cultural Center, Strawberry Bank Museum, Meadowlark Botanic Garden, Horniman Museum and Gardens in the UK, Key West Tropical Forest and Botanical Garden, and our very first zoo, the Oakland Zoo and Conservation Society of California. So welcome to all. I also wanted to mention we've recently redesigned our website and intake form on our website to better reflect our climate action goals and individual focus areas of sustainability. So if you haven't joined yet, but you've been coming to our talks, when you have a second, go and check it out. We're very excited about the new format. We think it'll make it easier for you to sign up and easier for you to take part. Stay posted this month. We're also going to be uploading some interviews soon about employee engagement, waste reduction, and biochar usage on our blog. And if you have a project that you'd like to share about in blog format, please reach out and we'd be happy to give you an interview. We love hearing about sustainability developments on your campus. As the presentation begins, you're welcome to use the Zoom chat function to enter questions, and Annie, our Climate Toolkit coordinator, will facilitate discussion of those questions after the talks have concluded. So without further ado, I'd like to welcome our first presenter, who's Dr. Adam Heathcote. He's the senior scientist at the Croix Watershed Research Station of the Science Museum of Minnesota. With that, I'll hand it over to Adam. Thank you.
All right, can everyone see my presentation and hear me okay? All right, great. Okay, well, thanks to Joe and Annie for inviting me to talk to you all. So this presentation is going to focus very briefly, since I've only got a few minutes here, on a couple research projects that the Science Museum of Minnesota has the Science Museum of Minnesota are working on, which revolve around climate change and water in particular. And then I'm going to spend a little bit of time talking about a few ways that we actually bring this kind of academic research to the public, to the audience, to our membership. So since I know that we have people from museums, botanical gardens, and zoos from around the world here, I first want to introduce you to our home. So this is the Science Museum of Minnesota. It's located downtown St. Paul, Minnesota, right on the Mississippi River, one of the largest rivers in the US. This is the largest public exhibit museum in the upper Midwest, United States. And it also has a very unique feature in that about 20 years ago, it established an environmental research institute on the banks of the St. Croix River, one of the first national scenic riverways in the United States of America. And so, as Joe introduced me, that's the department that I work in at the Science Museum. That's called the St. Croix Watershed Research Station. There we're a team of scientists and support staff, all working collectively on issues that have to do with water. And one of the ones that's become most pressing, particularly in the last decade, is the issues or the interaction between water or aquatic ecosystems and climate change. So even though we're located in Minnesota, we work all around the world. This is a photo from a couple years ago, a field expedition to Kangerlussuaq, Greenland. So this is the Russell Glacier here in the background, and you can see me, I'm in the tiny little Zodiac boat in the bottom right of your screen. And so, we have this challenge of we're doing research all over the world, and we want to make sure that our, the members at our museum see the importance of this research, realize why we're doing it, and understand that, especially in these Arctic systems, climate change is happening right now, and it's happening at a really alarming rate in some cases. So to that end, this area of Greenland is actually the fastest warming spot on the planet, but it's a unique study site because prior to about 2005, it was actually still cooling due to some complex climate forcing and atmospheric controls. But then in 2005, it basically sped up rapidly warmed and caught up and surpassed the rest of the Arctic. So it is now the fastest warming place on the planet, and it has warmed the most in the last 10 years. It has warmed about 5 degrees since 2005, which if you've looked into any of the kind of catastrophic forecasts, that's only, globally a couple of degree change would be major changes. And in Greenland, in this part of Greenland alone, it's warmed 5 degrees in just the last 10 years or so. You can see that map there. That little white box is actually the area we work in. It's the Kangerlussuaq Fjord. I'm standing at the glacial outwash in the photo on the bottom right. So that's what's called the Sander. So you can see, if you squint your eyes, the Russell Glacier is in the background there, and this is the actual discharge coming out. It's called the Watson River. So as I mentioned, this is kind of this unique system in that it was cooling for a while or not warming, and then all of a sudden it rapidly warmed. Kind of what we're worried about happening across the rest of the Arctic. Some of you may be familiar with some of the positive feedback loops that people are worried about happening as things like permafrost starts to thaw, and we get increased release of ancient carbon as carbon dioxide into the atmosphere. And so we're kind of seeing that happen, almost more and more every year in this region. So this is a figure from a study where we just looked at, it was an interdisciplinary study where we looked at everything from ice out in lakes to the size and strength of the caribou herd. And what we saw is that basically all of these things started changing non-linearly, so faster than even we would expect by predictive models after this 2005 change. And what this means is that this air temperature increase is having, as we feared, kind of cascading ecological effects in this area, seen in everything from microscopic algae that live in the lakes to the caribou and muskox, which graze on the tundra. And this is important because this site is kind of a bellwether for the rest of the Arctic and northern climates in general, because what's happening here is what we worry about happening in the rest of the Arctic in the coming decades. But not just, Arctic isn't the only place where we're concerned about climate change and its effect on water. We also work a lot in our own backyard in the north temperate and boreal forests. So Minnesota is blessed in terms of ecoregions in that we span everything from the northern tallgrass prairie in the southwestern part of the state to Canadian shield boreal forest in the northeastern part. So we have a lot of different ecoregions to compare and look at as this kind of this different interaction with climate happens to these lakes. This is actually a photo from a boreal area of Quebec, but it's very similar to parts of northern Minnesota. So as you might imagine, a lot of our membership, a lot of our visitors are interested in what's happening to the lakes right here in Minnesota. And so a lot of our work revolves around that too. So looking at how these lakes are changing as they warm. So there was a study out just a couple of years ago that showed that as air temperatures increase, actually water temperatures in lakes globally are increasing at an even faster rate. The fastest warming lake in the world is Lake Superior, one of the Great Lakes right here in Minnesota. And so what we've seen when we looked at a huge group of lakes spanning everywhere from Southeast Alaska to the west coast of Newfoundland, we see remarkable synchronicity in the changing ecosystem function of these lakes. This is related to both climate as well as atmospheric input, which can be indirectly or directly tied to climate. And finally, the other kind of area of research in terms of climate water interactions is looking at something called harmful algal blooms. So these are kind of these nuisance or even dangerous blooms of these microscopic algae that are happening in lakes all across the world. But where it's really troublesome is when it's happening in some of these northern, what we think of as our most pristine systems in the entire continent. The picture on the left is one of my colleagues at the Science Museum, Mark Edlund. And you can see that kind of scuzzy algae bloom he's looking at. You might think, oh, this must be a lake in some kind of impacted urban area or maybe an agricultural zone. This is actually a lake in the most pristine protected national park in the United States, Isle Royale National Park, which is an island in the middle of Lake Superior. The entire island is a wildlife refuge. And even there, we're starting to see these blooms with no obvious explanation, at least in terms of direct pollutants. And so one of the things we're increasingly looking at is as air temperatures rise and water temperatures rise, are these nuisance algae able to produce more biomass with less fuel. So are we moving the threshold to start seeing these blooms lower and lower as we warm water temperatures? The picture on the right is a satellite photo from 2019 of another lake in northern Minnesota. This is Lake of the Woods, the largest inland lake in Minnesota. So you can see this huge bloom. This southern basin of this lake is actually 50 miles across. So this is a bloom that's almost 50 miles in diameter, happening in a lake that's based in the Canadian Shield. There's almost no direct inputs in this system. It's actually main tributary is the Rainy River, which drains out of Voyageurs National Park, another pristine wilderness. So of course, this is a concern to us as aquatic scientists who are worried about things like water quality and climate change and how those things interact. But how do we reach the public with this research? And so, as a museum, we have a lot of different tools in our toolbox. We have kind of the first, maybe most obvious one. We can have exhibits, physical things on the floor of the museum. This was something that was installed in, I think, the winter of 2019. It was the Science Museum of Minnesota Science Superheroes, and we were just one small piece of this. It featured scientists all across the museum, anthropologists, paleontologists, all kind of featuring the science that's being done by the actual researchers at the museum. But our piece was kind of featuring how we go out and monitor lakes all over the world, looking at the impact of climate change on these systems, sometimes what we think of as the most pristine systems in the world. So that's kind of an exhibit, kind of a passive. Visitors would come look at this, learn on their own. But we also do a lot of active interpretation. So this was an activity that was done in collaboration with another department at the Science Museum, the Kitty Anderson Youth Science Center, which is a group a group that hires high school students from the Twin Cities metro area to come in and work as interns in an area that interests them. In this case, these were interns who were interested in environmental justice and in particular climate change. And so they developed on their own with help from us an activity which they could then show museum visitors, which kind of brought home the reality of climate change to people, right in Minnesota. So I talked at first about Arctic, about melting ice sheets. That's kind of far away from most people's mind. But here, even in Minnesota, we're already seeing these impacts, and particularly we're seeing the loss of cold water fishes. And a lot of these fishes are the ones that sports people, anglers, are pretty interested in catching. Things like lake trout, walleye, cisco, whitefish, lake herring. And so we developed this activity, including hands-on what we call our fish head collection. So these are like taxidermied fish heads, where we could look at what happens as water temperatures rise and some of these colder fish drop out, and how does that cascade up the food web, and you lose even some of these warmer water fish or more tolerant fish as you lose these cold water fish, some of which form the base of some of these food webs. Things like lake herring, lake whitefish, and cisco are some of the best food sources for sports fish like walleye and muskie, which many anglers in Minnesota are pretty interested in. And so those are things that we do within our walls at the museum, but we also have a major focus of amplifying our science outside of our walls. And one of the ways that we've worked really hard is by getting relationships with environmental or science reporters in the area or nationally. And so this includes agreeing to go. There's a weekly podcast on public radio in Minnesota called Climate Cast, where they talk about a different climate issue from a scientific perspective every week. And so we've been on there numerous times talking about how lakes, Minnesota is the land of 10,000 lakes, so people there care a lot about lakes, how lakes in particular are impacted by climate change. We've also worked with local reporters. The Star Tribune is the main newspaper for the Twin Cities metro area, and we've put several articles in there, both highlighting our research and other issues that surround it. And then, maybe more, something that's kind of a traditional media approach. Kind of a newer media or a social media approach is actually interacting directly with either followers or visitors or members who are interested in what the Science Museum is doing. So this is, your traditional social media platforms like Twitter, Facebook, Instagram, as well as maintaining a blog when we have, kind of high impact events like that expedition to Greenland a few years back, where we actually let people follow along live and we live tweeted as we were out there, collecting samples and making observations. That happened to be the warmest year ever in Greenland. So there was actually quite a bit of interesting things we were able to show them. So kind of in summary, I think museums are uniquely situated to bring climate science to the public. And I think that that is for a couple of reasons that are unique to museums. For one, museums, survey after survey has shown that museums are one of the most trusted sources of information for the public. We aren't seen as having an agenda necessarily. Another important one that comes from both interacting with public, but also from a management perspective, is that museums can often function as a bridge between governmental agencies, advocacy groups, and the public. And this is important because we can actually work across governmental agencies. We work quite often with state governments, federal governments, and even tribal governments, and serve as a bridge between those three groups that often don't work well together for various reasons. And then finally, museum researchers have a unique platform. We have a museum to directly showcase our research. We're not trying to go through a second intermediary. We can put it directly on the floor. We can amplify it directly through our social media and outreach specialists. And that's something that we don't often have inside academia, that museums are uniquely situated to do. So with that, I'll hand it off to the next speaker. And I'm happy to take questions during the Q&A session.
Thank you so much, Adam. And next up, we have Joe Rothleutner, who is the Director of Horticulture and Facilities at Santa Barbara Botanic Garden. So I'll hand it off to Joe.
Okay, I think you guys can all see my screen. Can I just get a confirmation on that? Awesome. So I'm going to talk a little bit about our story and what we're doing, but I wanted to kick that off first with kind of a little bit of a state of water in California and who we are and why it matters to us. So the Santa Barbara Botanic Garden, we are a collection of California native plants from all over California. And California is incredibly diverse in its amount of precipitation it gets, the seasonality of precipitation. And we're trying to display those plants here at one site. We kind of have a common garden for the state, which poses a lot of challenges, and it makes us water, and we water some areas a lot. And there's a big misconception or a disconnect with the public when we start talking about native plants. Often people will think, oh, none of these plants need water at all. So there provides an opportunity for us to kind of bring in and teach a little bit more, like the next layer, yes, go native, but then go water wise or lower water. And so the bottom arrow is Santa Barbara. So that's the county or the city that we operate kind of out of. And just to kind of let you guys know about our water, we get less than 20 inches of water a year, but there's areas in California that get almost 3 times as much water. And then there's places that get less than half. And this distribution is kind of interesting, and it's not exact, but if you kind of draw a line across the top third of the state, more than half the water that we get comes from Northern California, but more than 80% of the water demands actually occur in the southern 2/3 of the state. And that's because there's San Francisco, LA, the majority of the population lives down here for urban water use, but then also agriculture is really situated kind of here in the Central Valley. But then there's also quite a bit that happens down here along the coast. So water is something that we're kind of in a deficit locally on, but then even on a statewide level, we're acting in a deficit. We're pulling more water out of the environment than can sustain our current practices. With the future that we have in California with climate change, we're also really looking at huge consequences on how water is going to be delivered and how water is going to be both in volume, but then also in seasonality. So in the majority of our Mediterranean climate, we really get all of our water between the months of October and April throughout much of the state. And we're looking at a future with climate change where we're going to be going through climate extremes, from severe droughts to potentially very severe flooding. and get this thing that we're kind of a new term, at least a newer term to me, is this climate whiplash, where it's going back and forth between these two extremes and feeding into some of these other factors like wildfires in California, and then with these droughts, wildfires, and then heavy rains, potentially mudslides like we had in 2016, 2017, locally here in Montecito. And we're also overdue at this point for a great flood, or 100-year, 150-year flood. The last one was in 1862 in Sacramento, and literally the city was underwater. And some places in currently urbanized areas might see up to 30 feet of water over the top of the rooftops. So it's a very stark and very scary future, but we need to think about the solutions that we have in hand that we can start working with today to make water more available and use water more sustainably, not just here at the garden, but throughout the state. And so the garden can be positioned to help people understand and take away messages that can allow them to use less water, use water more responsibly, and work on reusing some water as well. This isn't one of our graphics, but I thought it was a nice way that kind of captures the four main water ways that we can kind of mitigate all of the impacts that we have, and that's through water reuse, through stormwater capture, through optimizing urban water use efficiencies, and then of course agriculture, but that one's a little bit further afield than the direct messaging that the garden can send guests home with. So when we are looking at the opportunities that we have on site, we develop what we call our waterwise home demonstration garden. And so this is a little Sears kit house that was built in the 1920s. And we've retrofitted the house itself to be able to capture stormwater that comes off of it. But then all of the downspouts, they feed some way into the landscape to be able to show different ways that people can use water and keep water on their site. And it's not just that we did it through graphics, but that we actually wanted to incorporate that into the landscapes as well. And so if you look at the graphic and then you look at our actual home waterwise garden, you can look at this graphic, you can follow it and look at it on the building and get a better understanding of exactly how this system operates. And it's a really transparent way for people to be able to see it and then take home information that they can directly apply in their own landscapes. Another example of what we have for demonstration and for interpretation out there, we talk about our dry creek beds. So this is where one of those other gutter feeds into a pipe that then comes out and daylights into a dry creek bed. This isn't just an interpretive, but it's also a physical element that's right there in the garden. And we take it beyond this as well, that it's not only these features, but then we have also a mulching display. We have information about plant selection, and we have publications that we did in partnership with the county to come up with a list of California native plants that can be used that are water wise. One of the big misconceptions or challenges that we are trying to demystify and debunk is that water wise plants are going to be your things like your aloes, your agaves, and things that are coming from other places in the world than right here in California. But we know that there's so many beautiful plants that are locally native that are water efficient and able to survive in our ecosystems, but then also that they are so beautiful and they provide all these other beneficial ecosystem services. We can bring in pollinators, we can help to decrease the water, we can be fire-wise with these plants, all kinds of things that they can do. We also are in the process of actually getting a laundry to landscape gray water recycling exhibit opened. Having this little cottage, it actually has a little mudroom that we're making into a laundry room. We have a washing machine and dryer in there, and we have the valves and the pipes, and we're showing people how simple it really is to retrofit to the county standards a gray water system to be able to actually irrigate your own yard. So it's a really neat exhibit that's up and on its way. And it's not just that we're doing it on the small scale, but we're doing it on a bigger scale as well. So this is our Pritzloff Conservation Center at the garden. So this is where the administration of the garden is housed, as well as our science and research team. We have a genetics lab, we have a multipurpose lab where we're doing all kinds of work on insects and pollinator webs. And then in the basement, we have our herbarium. And so this site offered an opportunity for us to develop a LEED certified building that does stormwater capture, but also it has solar panels, it has passive cooling, and it's meeting so many of these sustainability goals that we've set for ourselves. And it's a way that we can start to interpret it on site, but it's not necessarily as tangible or take home able for the homeowner. So that's why we have the demonstration garden across the street. But the Conservation Center, one of the things that has to do with water is that stormwater capture. And so the story on water is that it starts here in our parking lot, it runs into storm grates. Those storm grates collect the water, transport it down to a rill, which is a biofilter full of equisedum that brings out some of the other particles and things like that that we wouldn't necessarily want to go into our storage tanks. As the water moves down through that rill, it gets clearer and clearer until it goes into another drain that actually empties it into our 45,000 gallons of water storage on the site of the garden. And so I mentioned a little bit earlier about this very dramatic seasonality of our water here in California. So we're able to capture 45,000 gallons of water in these tanks. But that only happens for a portion of the year. And we need so much more water than that to support the surrounding gardens. So we actually take that water, and then when our well is, or when our water storage tank is getting low, we will pipe the water over here and fill up our storage tank, allowing our groundwater supply a little bit of a break in having to be filling this big tank. And then from there, we can turn on our pumps and irrigate anywhere in the garden using that water that we've captured from the site of the Conservation Center. So it's a pretty sweet system that we're able to store that water, because then if we have another rain event, we can capture another 45,000 gallons of water up there and hold it until we need to empty it into this tank again. So that's kind of what we're doing for stormwater capture. But I think one of the bigger things that we need to do, and I think a lot of gardens can do, is to make every irrigation drop count. So I've been here for 2 years, and a couple of my managers have been here for about that time as well. We just had a big transition in our staffing as we had a number of people retire after 31 years, 30 years, 17 years of working here at the garden. And all along the way, we kind of were taking this green thumb approach. So we're 96 years old, but we often find ourselves saying, or the gardeners who care for different spaces would say, oh, it's always dry here, so I turn on the irrigation system and I run it manually for a little bit more water, or the irrigation in this section never really has worked, and or nothing beats hand watering. And nothing beats hand watering, I mean, that's true to a point, because it's amazing to be able to actually have that interaction where you're seeing and you're making observations, and hand watering gives you the time to do that, but it's not necessarily the most efficient approach, both from a water resources point, but then from a time and staffing resources as well. So what we've taken on is we're starting to do a systemic audit of all of our programs, all of our valves, all of our irrigation heads, and we're doing it section by section. I have both my grounds manager, my facilities manager, and the gardener for that section coming together, and they're walking through it step by step together. And right now our irrigation system is on a centralized system, ICC Pro by Motec. By no means is a sponsorship for them, but the centralization of an irrigation system, I think, is a really important factor in this. If we had this tool available to us where we can have it all in one place, we can all look at it and see what is going on. And the really powerful thing behind this is that we can see communication errors, detect our leaks, and remove some of the unknowns. And so this is an example of what some of these lines look like. So we have the Porter Trail and Pollination Garden. So here's our main valve and a flow meter. We're actually able to see that there's no water moving through that system. And the system is off. That's great. If it's off, there should not be any water moving through it. Here we have our redwood section where the system is allegedly off. But we're seeing that we're having water move through there with our flow meter at 1.3 gallons per minute. And when I first saw this, I was talking to my grounds manager, and she was like, oh yeah, well, that's really not quite that much. But then when you start to think about it, and it's 1.3 gallons per minute, that's 1,872 gallons per day, almost 700,000 gallons a year. Starting to sound a little bit like a Rent song, but it's a lot of water that is going through that system from that small leak. So we need to figure out where that 1.3 gallons is going and get that capped off. And right now, as we're kind of going through and auditing the system, we're also finding that some of these valves, they just leak a little bit. So it might just be that there's a dribbling head at the end of one of these lines because the valve isn't completely closed. Or that in the case of the redwoods, actually, we had some redwood roots that had infiltrated into some of our lines, and the trees themselves might be sucking the water out. But we just need to figure out how do we cap that off and make sure that we're not just losing water consistently. The other thing that we're doing is we're really going through and we are making sure that we are getting any of our auxiliary systems integrated into that main system. So right now, our home demonstration garden that I mentioned earlier that has all that amazing water capture and interpretation, we have a clock over there because we thought at one point that we'd actually want to do some education on how do you manage an irrigation clock for your own home garden. That program really never got up and off the ground. People preferred some of this passive information, and getting into the whole clock thing was a little bit too much, and everybody's clock is going to be a little bit different. So we want to integrate that as well as some of our old systems that are just completely running on manual valves at this point, because if we don't have it on that main system, we don't have a way to shut it off. We don't have a way to easily see that something has gone wrong. We don't have anybody accidentally turning on a hose bib and leaving it run overnight and coming back the next day and finding out that our well is running low. And the way that ideally this system is eventually going to be working is once we have all of the irrigation lines communicating with our main program, we can then also integrate more information from our weather station and maybe put in some predictive formulas so that if we know rain is coming or that it has rained and we actually have water in our rain gauge, that we could water by less. And we actually get away from the idea of running our irrigation systems by time, not programming it to run 15 minutes. We're not running it saying we need to adjust from 15 minutes to 20 minutes, but that we can actually set a volume of water that we want to put out over an area. And we can start working from that because it's going to be so much more accurate. And we're going to be able to reduce our water use by so much by doing that. That's kind of the next step. The first step is actually just get everything working. And that's taking a lot of work, but we're getting there bit by bit. So that's kind of what I have for you guys today. But the garden is amazing. You guys should come visit us.
Thank you so much. Next up, we have Adam Haas, who is our interpretive program manager at Phipps, Water Management Strategies.
All right, I'm coming here.
Take your time.
I think I'd be better at the screen sharing at this point in our lives, right? All right, we're all good here. All right, sorry about that. So thanks so much for having me. I'm Adam Haas, Interpretive Programs Manager here at Phipps. As we've all heard, the reason we're here, water is this precious resource, right? And it's necessary. It costs a lot of energy too through conveyance, treatment, distribution, delivery. So we just want to be really smarter about how we are using it, not just for the valuable resource it is, but also as it applies to climate change. And of course, as climate changes more, water insecurity grows more, and it's sort of this vicious cycle. So we have to be better at it. And really the first part of this is, the less we use, the better off we are. And so from our approach, we looked at it, we did a webinar about carbon tracking. It's difficult to take steps to reduce your footprint if you don't have some detail about what that footprint is. So in 2012, we installed some more robust metering infrastructure. And this allowed us to look more closely at our water use other than just our meter coming in and how much we were using just as one big number. And we assumed irrigation was going to be a big part of that. But what we realized was that water features and processed water accounted for more than half of what our usage was. And so that surprised us. And so seeing, okay, this is an area that we can really work on, allowed us to look more closely at the water features. And so the facilities department kind of made this systematic approach where they could start going through each water feature, each waterfall, fountain, all those kinds of things, and checking out. And it's not really super sexy, but it was things like patching them, resealing them, making some repairs, then adding fills for these features that have control boards and timers and level sensors to reduce waste, and it reduces human error. It's a big part of it. And then in the outdoor garden, which is this picture here, we had already planted climate appropriate natives, or at least climate appropriate plants. And so we had this underground irrigation system that we had shut off. We weren't using it anymore, but we realized there were leaks in the valve boxes. So this system that wasn't even being used, we were losing a ton of water through tiny leaks in that. And so, making our way through these steps, and like I said, it doesn't sound like the most innovative, or sexiest approach, but 2 years after this, so in 2014, after we made these changes and looked, our total water footprint was down 45%. So we almost cut our water use in half by not particularly, huge investments. It took some time, took some effort, but it was certainly attainable, and it wasn't any crazy capital project that was, really, really difficult. And so, there are a lot of ways to look at the water you're using, and maybe in unexpected places. The more you know about where that water's going, the better you can address what's going on. And so the other thing I wanted to talk about is not just conservation and being smart about, using less, but particularly germane to Pittsburgh is water management, and specifically rainwater management. And Joe just talked about climatic conditions out in California and how varied they are across the state, and where they are in Santa Barbara compared to up north. I think it's really interesting sort of juxtaposition to go right after him, because the problems Santa Barbara is facing and parts of California are totally different than the problems with water we're facing here in Pittsburgh. And each of us has a different garden or institution. We're all in different climates. We all have unique places, ecosystems, climates. We're all going to see different issues, although the overall principles behind this are the same. But Pittsburgh is really rainy. My wife, she's not from Pittsburgh, and she reminds me all the time how much it rains here in Pittsburgh. It's about 40 inches per year. I know these graphs are really hard to see, but what is important about them is this dark green section. That dark green section shows above average in the past. This is 18 at the top left, 2018. We hit almost 60 inches that year. We had 57.7 or something like that. And then the next year we were up above 50 again, 53 inches basically. So not only are we a rainy place, but with climate disruption, we're going to see greater volumes in what's panning out. The next year was pretty much on par. We were at 39, and this year. We're pretty good. Then we just hit a couple big storms here, and we're back above the average. And so to drive, really lean into this juxtaposition, here we are this year in Pittsburgh, compared to, I looked up Santa Barbara yesterday to see. And so as of yesterday, or at the beginning of September, this green line for those folks out there is their accumulated precipitation. They're just over 5 inches. We got about that since September started, and we're a week into it. And so, again, different gardens, totally different challenges, but these same principles apply. In Pittsburgh, it's about figuring out better ways to deal with this water that we are getting. It's this precious resource. It's falling right on our heads, and our goal is to get it away from us as quickly as possible, and then process it and spend energy to pump it back to us. So one of the biggest issues we face in Pittsburgh with rainwater and rainwater management is that we're on a combined sewer system. And so there's a lot of cities, especially older cities in the East Coast or Midwest, have combined sewer systems. So these diagrams, the one on the left is what would be preferable. That's a separate sewer system. So you see the house has its downspout, goes into this storm drain. Here's the storm drain on the road, pops down. It has its own pipe, and it can go to an outfall that can then go into a river or somewhere else. And then you have this other pipe with all the sewage represented by the brown water here, going from all these sewer lines to Alcosan, which is our sanitation authority, Allegheny County Sanitary Authority. That's ideal. What most of the systems in Pittsburgh are a combined sewer system. And so you have one pipe that conveys both the sanitary and the stormwater, which when it rains, which as we just saw, it does a ton here, and it's a little as a 1/4 inch of rain. It's not like these big 50-year rain events of a few inches in a couple hours. This is 1/4 inch of rain, 1/10 of an inch of rain, which is commonplace here. The volume of water entering this combined pipe is too great for the capacity. And so you have sewage and stormwater, too much for the pipe. So you have to open up these sluices that then have outfalls that pipe out to the river. So you're putting untreated sanitary water mixed with rainwater, and that's going directly into our waterways. So that's not good. That's very bad. And in Pittsburgh, this is Pittsburgh. If you've never been or never seen, this is kind of our iconic view. So for the city of bridges, we have the 3 rivers. We have the Monongahela, meets the Allegheny, makes the Ohio, forms the Ohio at the point which you're looking at, the Ohio down to the Mississippi, of course, the Mississippi to the Gulf of Mexico. So there's a lot downstream from Pittsburgh. And these waterways are why we are even on the map, why we even exist. And so, we love this image, the inclines in the forefront there. And so we love our rivers, we're proud of them. But, as a thought exercise, I challenge you to take a stab at how many gallons of this untreated sanitary water mixed with rainwater that we're dumping into these riverways each year. And I'll give you 5 seconds to just come up with a number. So how many gallons? And so the answer is, get ready, wait for it, 9 billion. So that's billion with a B. And really, that's a pretty conservative estimate. It's probably more than that. It was probably more than that when we were getting 40 inches of rain per year. And now we're getting more than that. So it might be quite a bit higher. So this is bad. And it's a violation of the Clean Water Act, and Pittsburgh is in a consent decree with the EPA to mitigate this. And this is going to be a several $billion-dollar project, and years of feasibility studies and how much more can we charge for suit and all these things. And the wet weather plan that was put out a couple of years ago was basically bigger pipes. So not the most resilient or regenerative approach. So the lower campus at Phipps, which is the sort of bottom half of this picture, which are all the newer sort of part of campus, which has been added in the past decade or so. The lower campus manages all the water, so rainwater and sanitary water. So nothing leaves. So whatever falls on it stays here and either infiltrates into the ground or is captured for reuse or is captured for cleaning and reuse. And so it's about 3 acres, this site that's net zero water. And so, a drop in the bucket for how much rain we're getting in Pittsburgh But it's a site that demonstrates the ways that we can right now treat water like the precious resource it is, and at the same time help stop dumping 9 billion gallons of sewage in our waterways, which is also where we get our drinking water, by the way. So that's a really, how should I say, effective way to talk to the public. You know, it's a little bit of a gross out factor, but, you know, hey, we're dumping sewage in our drinking water. You know, you want to learn about how we can't do that. So the idea here is we're able to model not only, hey, this is possible right now, but this is a series of scalable solutions. And so we're saving water, we're helping the ecosystem, and of course we're saving energy as well. We're fighting climate change at the same time. So it's basically two different systems, but there is some overlap, but it's easier to think of them as two separate systems. So quickly, what happens when it rains here? How are we capturing this? So starts to rain in this A here. This is the tropical forest roof. This is going to go down a downspout and end up in the green holding tank. It's basically a 1,500 gallon underground rain tank. It collects water from the CSL roof as well. And then that feeds the hose bibs of the building. So should a horticulturist need to water something in the landscape, it's just captured rainwater. But since this landscape's been established for a few years, it's all native plants, we really don't need to irrigate it much. So that drains into this lagoon, which is this really beautiful water feature. It's very engaging, people love it. There's fish and frogs and aquatic wildlife in it. We just had a heron out here yesterday walking around, which is really cool. But it also holds about 100,000 gallons of rainwater. That overflows, because again, you saw those charts of how much water we get. That overflows into 60,000 gallons of underground storage that we can tap from to use for irrigation. So beyond that, those systems, the rest pretty simple construction strategies like curb cuts that go into rain gardens, the permeable pavement for the parking stalls, and asphalt that's graded towards these curb cuts, things like that. So with those strategies in place, we opened about 10 years ago the CSL, and ironically, we've had probably 6 10-year storms in that time, which tells you something about the way things are changing. But we do have storm drains that we have a meter on, so we can tell if we're sending anything to that system, and we haven't seen any. So we're maintaining all this on site. We're having 10-year storms, and we're able to capture all that water still. And quickly, I know we're running out of time, so I'm going to really quickly run through sanitary water. Basically, anything that goes through these buildings back here, that's through a toilet or through a sink. There's no segregation of black and gray water here because Pennsylvania doesn't define gray water. So everything that goes through a drain is black water. Goes into a settling tank. And then we pump that into a constructed wetland, which is right here, which is, right adjacent to the building. That goes then through a sand filter. The sand filter, water percolates down through that, goes through a pump station to get a UV filter, and then right back to a holding tank to flush toilets again. So this water is going around and around and around in a closed loop system. So it's a really kind of beautiful and achievable way to address some of the issues we're seeing here. And lastly, just about how do we communicate this? To do all this is one thing, but it's imperative to talk about it. And these are great stories to tell. Water is something that impacts all of us. It's different what impacts people in Minnesota with algal blooms, what impacts people in California where you can't wash your car. In Pittsburgh, I have water in my basement every time it rains too much. My kids had school canceled last week because it rained too much. And instead of, it's the first time that happened to me, but I had snow days. Now my kids are going to have snow days and rain days. So water impacts this, and so it's a right material for talking to folks about it. Here's that lagoon on the lower campus, and there's a class. Here's another field trip, and it's such an engaging space, and we're just drawn to water as human beings. Maybe evolutionarily, we came from there. Maybe that's why. But we program around it, and there's super popular classes. and programs because it's such an engaging topic. The other thing is, you know, what we try to do at Phipps is not just say, hey, you should save water because it's better for the environment and all these things. That's important, but we try to make it as comfortable and beautiful as possible. Like Joe mentioned, you know, these spaces that are engaging to people are going to be engaging to people regardless of their, you know, how they voted in November, right? The people want beautiful spaces, and when they can see it, just makes more sense that this is the way we should be building things, the way we should be doing things. This is better for you. This is better for your family. That's a sort of place where you can get traction with all your different audiences. This is the green roof of the CSL you're looking at. This kid, you know, he doesn't care about green roofs necessarily at this point yet. Green roofs are awesome because one of their many, many benefits is storm runoff mitigation, but they're just beautiful spaces and they're engaging. And so it's that nexus of this is better for our visitors. They see why this is going to work. They see why they would want this. And oh, this also is good for the ecosystem. So I'll end here quickly by just saying another audience that we want to focus on at Phipps is not just the guests that come here, but the governmental agencies. Like Adam mentioned, you know, we're a liaison. We're sort of in between the public and the private and the governmental sectors. So we have governmental agents, regulatory agencies that come here that needed to permit our systems, and they had not seen systems like before. And it was a lot of back and forth and kind of glacial movement on, can we do a toilet water cleaning system? And, you know, it was a pain, but we did it and they permitted it and they've seen it work for 10 years. And so now there's a precedent. And so now we can say, come out, check this out, look how well it's working. The next project that's going to try something like this has it that much easier because these systems are not brand new now. They're something that they've seen and that they're able to say, yeah, this is something that's viable. And so that's an important audience too, that I feel like we sometimes forget about, but hugely important and can, again, scale these solutions up at the state or even wider level. And with that, I'll stop because I know we're awfully close to our time.
Thank you so much, Adam, and thank you to all three of you for the presentations today. I really think we got through a lot of aspects of the issue, but I did want to open the floor. I don't have anything in the chat, but if anybody would like to, you know, you can feel free to turn on your cameras and say hello if you have any questions for the group today. If not, that's of course all right too. I know we're getting close to 5. Well, I did want to just thank everybody so much for making it out today. This will be posted on our website subsequently, so you'll be able to share it with others. If you know anyone who would get some use of the information here. And we'll send that link to you in the coming week. In the meantime, we hope you'll check out the new redesigned website at climatetoolkit.org, and if you haven't already, and we'll look forward to being in touch with you all. Thank you so much and have a good day.